Hey, sixth grade. We have a really cool lesson today. So our title is Read and Write Expressions in which letters stand for numbers. So we're getting a little bit deeper into some algebraic expression work, and our objective is I can read and write expressions with letters, and I can also identify parts of an expression. We're going to start off by recording some notes. This is a review. And so these are our operation words. So I made a thinking map that organizes all of the words that have to do with addition, subtraction, multiplication, division, and exponents. And I do want you to record this into your notebook. And then when you're done, you can press play and keep going. So now that you have the operations words recorded, our next step is we're going to be writing some expressions in word form. So I have letter A, B, and C. Let's start with these and write them in word form. And you might have another way to write these in word form, and that's going to be totally normal with these kinds of problems. There might be more than one correct way to say this in word form, but these are some possible answers. So for A minus B, we could write that out in words. A minus B. We could also write the difference of A and B. We could also write A decreased by B. We could write B subtracted from A. So there's a multitude of ways that we could write these. We'll just record a couple. If you hear one that I say that I don't write down, you can always write that one down in your notes as well if you like how I said it. For B, we have X next to Y, which we would say X times Y. So I'll record that one first, X times Y. We could also say X multiplied by Y. Or we could say the product of X and Y. For letter C, we have 4 times F plus P. So one way that we could say this one is P added to the product of 4 and F. You could also write it how I said it the first time, which would be 4 times F plus P. Or you could say the sum of 4 multiplied by F and P. All right, so now we're going to move on to the next chunk. And so we have D, E, and F. And those will be the last 3 problems that we do in this screencast that are like this, where we have to take an expression and write them in word form. So for D, we have a couple ways that we could write this as well. So let's start with D minus B cubed. We could also say the difference of D and the quantity B to the 3rd power. Oh, that's Stella and Lady being my guard dogs. Let's see. For E, a possible answer for this one could be 5 times the quantity of U minus 10, and then the very last part of that one would be added to H. And then another way you could say that one is actually add H to the product of 5 and the difference of U and 10. And so then our very last one, F, says 3 divided by the quantity D plus F. You could also say the quotient of 3 and the sum of D and F. So there is one way that you could write this that is not correct. And so I wrote this down as a question at the end for F. It says, why is 3 divided by D plus F not a correct answer? So that's one way that you actually could not say this one. And so the reason is because that would indicate or mean that we divide 3 and D first and then we add F. But that is not what the expression shows. The expression shows that we have to add D and F first and then do 3 divided by that sum. So you have to be very careful if there's more than one operation going on within your expression, because you don't want it to be not following the rules of PEMDAS or the order of operations. We need to make sure that if we have to divide first and then add, we do that. If we have to add and then divide, we put it in the correct order. Okay, so we're gonna keep on going with our notes. For the next chunk of your notes, I actually want you to record this in your notebook first, write all of this down, and then we're going to go through it together. So you can go ahead and pause, get all of this written down. And so now you should hopefully be unpaused. It says circle all of the vocab words that could be used to describe the expression. So we're actually just gonna go to number 1. We have 6h minus 10. For this expression, we see no addition. So we're not gonna circle addition, but I do see subtraction. So we could use the word subtraction to describe this expression. We circle it. We also use multiplication. I didn't write that one fully out, it just says mult, but that stands for multiplication, and there is no division. Okay, for number 2, we have 5 times D over 6, or divided by 6. So sum, that means addition, we won't use that. Difference, that means subtraction, we won't use that. But product means we multiply, so this word does describe that expression. And so does quotient, because like we learned in one of our previous lessons, if we have a fraction bar, that actually means divide. So in this expression, we have these two. Okay, for number 3, we have 5 times the sum of 2 plus D and then minus 8. So we have a lot going on here. The 5 in parentheses next to it, that means we are multiplying. So multiplication will describe this expression. Within the parentheses, we're adding. And at the end, we subtract 8. So this one has 3. Nowhere in this expression will we be dividing though. And then for number 4, we have A times B times C, or the product of A, B, and C. So more than will not describe this. That means adding, so that doesn't work. Less than means subtracting, so no. Each would be division, so no. But we are multiplying, so we can use times to describe this expression. All right, the next chunk, you do not need to write. I even wrote it here. Do not write. I hope you have your headphones on and that you can hear me, because this next half of the page, there's a lot of writing and I don't want you to write it unless you think it's an example that you really want to stick in your head. You really want to keep it. It's a good example for you. You learn something, then you can write it down. But otherwise, I just want you to sit back and listen and watch. So we're going to be writing expressions using vocabulary words, kind of like we did on the previous page. However, these expressions are a little bit more complex than we did on the first page, and there are multiple ways that you can record them, and I wrote down all of the ways that you can record them. So it's going to look like quite a bit of writing, but you don't need to write them. We'll start with 8 minus 2g. So you can write this one a few different ways. I wrote in blue 8 minus the product of 2 and g, but you could also write 2 times g subtracted from 8, and you could also write decreased by g doubled. So here's g doubled. Oh, decreased we would have 8. There we go. 8 decreased by G doubled. For the next one, 15 times the sum of A and C, we would have, in blue, here I wrote 15 times the quantity of A increased by C. You could have the product of 15 and the sum of A and C, or you could also have 15 multiplied by the total of A and C. M plus N over 5. You could write the sum of M and N divided by 5. You could write the quotient, since we're dividing, of the total of M and N and 5. You could also say M plus N split into 5 equal groups. I really like that one. Our next expression has an exponent, and it's a 3, so we need to make sure that we say cubed instead of squared, or we could say to the third power, the power of 3. In blue, I wrote the first option. You could write b cubed minus 18. You could also say b to the third power decreased by 18. For number 9, you can already see my 3 answers there. F minus the quotient, since we're dividing here, of d and 2. You could say d split into 2 groups and then subtracted from f. So that one you start with this and then take it away from the f. Or you could say d divided by 2 less than f. And then here's our last one. U divided by x. You could also say the quotient of u and x, or you could say u divided into x parts. So this is why I didn't want you to write it all, because when you look at it all, it's a lot. But I will leave this here for a second in case there are any that you want to write down, even if, like, for one of the expressions, how I said I really liked this way to say it, you can write down one of the options for one of the expressions. It's totally up to you. But hopefully hearing it and seeing it was a good exercise just to practice some visual and auditory learning skills, and to see that there's a ton of different ways that you can say these and write them in word form. So you might have teachers in the future or people around you at your table groups that use different language than you, but it means the same thing. So it's really good to get all the practice you can get hearing it and seeing it a bunch of different ways. All right, so we're gonna move on. And so for the next chunk of our lesson, I do want you to write. You have to go back to writing now. This is important and you need to write it down. So for the next chunk, you're gonna make a T-chart in your notes. And your T-chart will look like this, where you have expression in word form on this side, and then on the other side, the expression in standard form. On this side, we'll be writing the expressions out with letters and numbers and math symbols. But we're actually going to start with the first column, expression in word form. So for A, make sure you write that down, sum of twice B and 5. For this side, I want you to write down the expression, and then you have to highlight the keywords in each statement. So the keywords would be like the operation words that we saw on the first page of our notes. Any keywords that you see, I want you to highlight. So in this one, I see sum is a keyword, and also twice. Okay, and that's it. We're just gonna keep going down this column. So for B, the quotient of C and D, our keyword here is quotient. For C, it's a little bit longer. A raised to the 5th power and then increased by the product of 5 and C. There are actually 3 keywords here. One of them has 2 words, but there are 3 total that we're going to highlight. So you should highlight power, increased by, that one kind of goes together, and then product. For D, we have the quantity of A plus B divided by 4. So here we have quantity plus, and then divided by kind of go together. E, 10 less than the product of 15 and C. We have less than and then also product. And then F is our last one, 5 times D, and then increased by 8. So increased by is one of them, and then also times. So now we've highlighted all of our keywords. That's going to help us as we turn these written expressions into standard form expressions that use letters, numbers, and math symbols. Okay, so if we go back up to A, and I'm just gonna go like this, so that we can focus on one at a time. If we go up to A, we highlighted sum and twice. Sum indicates that we're gonna be using addition, and twice indicates that we'll be using multiplication by 2. So if I write that as an expression, I know I'm gonna be multiplying something and I'm gonna be adding something. The sum of twice B shows me that I'll be doing 2 times B and then adding that 5. That is how we would write that expression in standard form. For B, we highlighted quotient. Quotient implies that we'll be using division. So I could write this as C divided by D and also C over D. A raised to the 5th power indicates exponents, and A raised to the 5th power would be written like that, and then increased by the product of 5 and C. Well, increased by implies addition, so I'm taking this A raised to the 5th power and then I'm increasing it by the product of A and C. Well, the product of 5 and C, that tells me I'll be multiplying 5 times C. All right, we have the quantity of A plus B divided by 4. Quantity indicates parentheses. This wasn't really on our first chart, but when you see the word quantity, it means parentheses. So I know I'm going to have something in parentheses. The quantity of A plus B. Oh, that's what's going in parentheses. A plus B. The quantity of this, we have the plus, which means addition, and then divided by 4. So all of that divided by 4. I could also write this one using a division symbol. So A plus B divided by 4. Like that would also be correct. All right, we're almost done. We have E and F. So for E, 10 less than the product of 15 and C. Less than indicates subtraction, and product implies multiplication. So 15 and C are being multiplied, and then it's 10 less than that product. Now, if you wrote this one as 10 minus 15C, your terms would be correct, but they're not in the correct order. It's 10 less than what we're starting with, so this would actually be marked wrong. So you have to pay attention to that order in which they're going. Even though 10 less appears first in the written form, it actually is happening second when we write it out in mathematical form, in standard form. And then F, 5 times D, and then increased by 8. Times indicates multiplication. So I know I'm going to be multiplying 5 into D, so I can write 5D. And then increased by, well, that implies addition, 8. Since addition is commutative, we could take this entire term and this entire term and switch them around. So if you wrote 8 plus 5D, that is also correct. All right, you guys, so for the last part of our lesson, you actually don't need to write anything down again, but I do want you to follow along with what I'm showing on the screen. It's super important because we're going to be looking at some problems that are in real world scenario, word form, as we're moving forward. So I'm going to zoom in here, and I want you to look at it right here. Marcus has $4 more than Yassine. If Y is the amount of money Yassine has, write an expression to show how much money Marcus has. So they're telling us here, in order to do this, we have to underline the keywords. Well, Marcus has $4 more than Yassine. And now, if we want to put this into standard form, like we just practiced in our notes, we can just plug in or substitute in some numbers because they don't actually tell us how much money each person here starts with. So let's say Yassine had $7. If Yassine had $7, how much money would Marcus have? Marcus would have $11 because if Yassine started with 7, Marcus has 4 more than him. 7 plus 4 is 11. We see that right here. We added 7 plus 4. And now I can write an expression, but I'm going to use Y for the amount of money that Yassine has. So I can plug in a variable because we don't know how much money he's starting with. We could have plugged in 7. We could have plugged in 10. We could have plugged in $500. We don't know how much he's starting with, but we know that however much he has, Marcus will always have $4 more than him. So our expression could be Y plus 4, and then it's always true. Let's look at another one. Mario is missing half of his assignments. Oh no. If A represents the number of assignments, write an expression to show how many assignments Mario is missing. So if we start out by looking at the keywords, Mario is missing half of his assignments. We don't know how many assignments he started with. So let's say he was assigned 10. That means he's missing 5. And we got that by doing 10 divided by 2. But what if he didn't start with 10? What if he started with 70 or 34 or 6? We can put a letter in or a variable in because we don't know what he actually started with, but we know that he'll always be missing half. So we could write an expression using A for the number of assignments that Mario was assigned. We could say A over 2, or we could say A divided by 2. All right, we just have one, let me see. 1, 2, 3 more. Camilla's weight has tripled since her first birthday. If W represents the amount Camilla weighed on her first birthday, write an expression to show how much Camilla weighs now. So if we look at our keywords, Camilla's weight has tripled since her first birthday. Tripled, we know that means multiplying by 3. If Camilla weighed 20 pounds on her first birthday, how much does she weigh now? Now, they don't actually tell us that she weighs 20 pounds in this problem. She could weigh 10 pounds. She could weigh 15, 17, 23. They never tell us. So we're just plugging in a random number. If she weighed 20 pounds, then now she weighs 60 pounds. And we got that by doing 3 multiplied by 20. That means if we used a W for Camilla's weight, which we don't know what it really is, but if we just used a W as our variable, we would always be doing that W multiplied by 3 because we're tripling it. And that expression would help us find her weight no matter what she actually weighed in that problem. Okay. Nathan brings cupcakes to school and then gives them to his 5 best friends who share them equally. If C represents the number of cupcakes that Nathan brings to school, write an expression to show how many cupcakes each of his friends receives. So if we look at the keywords in this problem, Nathan brings cupcakes to school and then gives them to his 5 best friends who share them equally. That implies division, right? So let's pretend like Nathan brought 15 cupcakes to school. Now we don't know that for sure. We're just picking any random number that works for this. So 15 divided by those 5 equal friends would mean that each friend is getting 3 cupcakes, right? So the question said, if Nathan brings 15 cupcakes to school, how many will each of his 5 best friends receive? They'll each get 3 because we did that 15 divided by 5. And we don't actually know that it was 15. So we're gonna use C to represent the number of cupcakes that he might bring to school. that would be C over 5, C divided by 5, or you could write it horizontally this way, C divided by 5. Okay, and so our last one is Mrs. Marcus. She combines her atlases and her dictionaries, and then she divides them among 10 different tables. So pretend like I gathered all of our atlases and dictionaries in our room, and then I put them into one big pile, and then I wanted to divide them so that there was an equal number on 10 different desks, okay? If A represents the number of atlases and D represents the number of dictionaries that Mrs. Marcus has, write an expression to show how many books would be on each table. If we look at the keywords, Mrs. Marcus would be combining her atlases and dictionaries and then dividing among 10 different tables. So that shows me that I'll be adding something together, that's combines, and then dividing them by 10. So to finish this problem, if Mrs. Marcus had 8 atlases and 12 dictionaries, do we know that for sure? No, we're just picking random numbers. How many books would be on each table? 2. How did we get that? Well, if we add the atlases and dictionaries together, we would do 8 plus 12 is 20, and then 20 divided by 10 would be 2. On this example, you can see that we don't know how many atlases and we don't know how many dictionaries, so we'll need to pick a variable for each of those things. We used A for atlases and D for dictionaries to represent how many books each table would receive. So you could write this one as A plus D, that's atlases plus dictionaries divided by 10, or you could write it out this way with the division symbol, A plus D, then divided by 10. All right, you guys. We're done. You made it to the end of our screencast. Thanks so much.